Well, hello and welcome. It is time once again to try to fix something. I've got another PS4 FAT here that is supposed to be totally dead. So let's see, I've got power plugged into it back there. No. We don't even get a beep when we hit the eject button. And that generally tells me that the power supply is dead. We don't even have 5-volt standby. No, it is still possible we got a short on the main board that's killing the standby voltages, but that's not very likely. This may just be a dead power supply. We get to fix another one of those. I did notice it is sealed. Looks to be factory original. It's got a lot of dirt in it. That's not factory original. But we can clean it up after we get it working. So let me get the covers off of this, and we'll try our test supply in there and see if it's just going to be the supply this time. Okay, just got the bottom cover off. And wow, that is fuzzy. Nasty. Okay. Does the fan spin? Somewhat. Okay. Before I do any cleaning, we'll just swap out the supply. I just wanted to show you that this thing is nasty. Let me get the supply out. Alright, well, the suspect supply is out. Very, very dirty bottom case. Test supply is in. And monitor is on. Let's just see if we have any life. Now, let me hit the eject button. We have standby power now, so I think we're going to be in good shape. Get this thing flipped over so we can see this LED. Okay, flashing blue to start. Come on. Monitor has not seen anything yet. Not another blue light of death. That is weird. It hadn't been opened. Oh, there we go. White light. No video yet. Could we have a 2-for-1 here? Bad HDMI and bad power supply? Wiggle that. No video. Okay. One. A hell of a bargain. So, all right, we've got a power supply to fix. And let's take a quick look at this HDMI port and see if we can see anything. I guess I can just try to shut this thing down. I hate just crashing them down. Let's see if she'll shut down. There's the first beep. Well, it didn't give me the second beep. But it did shut down. Okay. Couldn't really see what state, it was in the software. Okay. Let's see what this HDMI port looks like. Well, at first glance, I don't really see an issue. Of course, it could be broken loose from the board in there. All right, we'll get this apart, get it on the workbench. We've got to fix that power supply and see if we can figure out why we have no video. That stuff's not wanting to come out of that fan. stinks. I'll have to give it some more scrubbing once that fan is out of there. Alright, well, all of the chassis or cabinet parts will be getting a nice spa treatment. Soak in some soapy warm water while we are next door working on the electronics. So let me get you set up in a tripod and let's see what's wrong with this stuff. Alright, let's take a quick look at this HDMI port. I'm going to keep bumping this camera, I can tell. Just the way it works out. Let's take a look at it. I'm just kind of curious if we actually have a problem there. Take that little RF shield off. That looks very nice. Yeah, this all looks really good. Okay, because what I'm wondering is, I'm going to check it with the breakout board. Maybe we don't have an HDMI problem. Okay, maybe we don't have an HDMI problem because this console did not have a hard drive in it. And I've noticed in the past, sometimes if there's no hard drive in there, it takes forever for it to finally say, hey, I can't find the system storage. So maybe I didn't wait long enough is what I'm wondering. Let's do a quick diode check of these pins though on this thing. Red probe on ground. That's 8.2. That should be grounded. That looks odd. It looks really low. Keep going. That looks low. Yeah. And that the readings are just all over the place. 1.76 and a dead short on pin 8. Okay. You know what I wonder? I wonder, that's dead shorted there. I mean 0.03 volts. I wonder if this is a lightning strike. Took out the power supply and the HDMI port. Pin 13 is dead shorted to ground. 14 is nothing. 15 is shorted. 16 is shorted. 17 should be grounded. 18 is plus 5 volts. It looks fine. That's, you're reading the Zener diode that's across the plus 5. And 19 is open, and it should not be open. So, yeah. I'm wondering about a lightning strike. Let me see. Let me take a look at the back side of the circuit board. Because if it took a strike, well, if there was an Ethernet cable plugged in, it would have popped some other components. Let's take a look. No, this one doesn't have the resistors where you can easily access them. I'm thinking about the slims. Let me look back. This is the back of the HDMI port. All that looks fine. I see nothing missing or blown off the board. Let's look at the HDMI encoder IC itself. If I can get it in focus here. Well, there's no holes in it. What if we check, you know, all around it there are these little filter caps for bypassing the supply voltages going in. What if I check across that? Ooh, a dead short. Shorted there. What about over here on this one? Also shorted. There's another one up here. Okay, so we've got a dead encoder IC. I think I have some of those on hand. Just wonder what else it may have popped. How about this fuse going to the HDMI port? No, it's fine. It's fine. What about these filters? I'll just go to regular continuity mode for that. Let's just see. Good. Good. Of course, it's 40 ohms across the two because we have a short up in the IC. Good. 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 Okay, so I think the filters are probably good. I think this IC has died in a valiant attempt to defeat lightning. So I'm wondering, there's no signs of roaches anywhere in this thing. So I'm kind of wondering if our power supply is going to be a similar type issue with some lightning damage. See if I can, let's just see if we can get this supply open. And once again, please do not open up your power supply unless you are quite experienced in working on things like that, because there are lethal voltages inside of it. All right. I don't believe this has ever been opened, so it may put up a fight. Let's see. No, not too bad. Whoa. Okay, that was unexpected. Get it out in our hands. You notice I grab it. Oh, there's a roach. There. Oh yeah. Yep. Yeah, we have one roach come out dead. Very, very dead. I don't know if you can see him. Over here. Yep. A former resident. So, and we do have, you could tell there's been roaches up inside of this thing. I'm not sure if you can see it in the light there, but yeah. Okay, so maybe we can kind of explain that. Oh, I see remnants of another one across the main filter cap right in here. I think this was in a smoker's house because everything has a film on it, looks like. All right, let's just see what we blew. We're in continuity mode here. Main fuse is still good. This fusible resistor here, it's still good. That's surprising. That is surprising. They usually go when something shorts. So, do we have a short? I don't know what value that resistor is over there. But the fuse is good. We're very dirty. So I don't know. Let me check. Here's what is this, Q9? Check some of these MOSFETs around here, but I'm kind of doubting I'm going to find a shorted MOSFET, because one of these fuses would have blown if we had a dead short. Oh, that's that diode. Two diodes in one package, or a TO220 package. What about these MOSFETs right over here? Is that the ones? That's not the ones I'm thinking about. We don't seem to even have +5 standby, so I want to look in that area first. which is right here. This is IC31, which I'm not sure. Let me see what model that IC is in this one. Well, focus, focus, focus. DAP41. Make sure that shows up. DAP41 IC, which I think I have some of those on hand. Let's just do some quick checks around there. That DAP41 is driving a MOSFET right next door, right over here. And which I doubt this MOSFET is shorted, like I said, because we would have blown a fuse. Okay. No dead shorts. What about on this IC31 here? DAP41. Let me find a good ground. A really good ground. I believe that is a good ground right here, because this is the return path for this MOSFET. You can see right here. It's through these two resistors, which when that MOSFET goes, this thing usually opens up. There's a 2 ohm and a 2.2 ohm in parallel. They seem fine. A lot of times when these go, this Zener will go also, and you don't realize it's went because it's such a low resistance. It's in parallel with basically, you know, one ohm of resistance. So if you check this, it should measure about 1 ohm and not 1/10 of an ohm, which is what it'll measure when this Zener is shorted. But I think we're good there. Let's just check. Like I said, I think we'll put the red probe right here. And we will check some of these leads on this DAP41. Pin 1, 2, 3, 4, which is possibly ground. I'm not sure though. I have to look at the schematic. 5, 6, and 8. So only one pin connected to ground. That would lead me to believe that that is the common. I'm trying to follow the. There he goes. Here, 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 here. Not sure where all it goes. Let me look at the DAP41. 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 Here we are. See if I can find. Yeah, pin 4 is ground. Let me just show you. Here we are. That's the DAP41. That's its application example. You can see all the pins over there. But DAP41 is definitely, I mean, pin 4 of the DAP41 is definitely ground. So I think we're fine there. So nothing obvious so far. If I can get you back in the tripod. There we are. So, it's not going to make it easy on us. I suppose what we should do is plug it in and see if we get standby voltage. I just don't think we will, because it's didn't seem to have it in the chassis. Let me get this other dead roach carcass out of here. Nasty. Okay. And let's just check right quick like. Do we have a short across our main B plus, which we really shouldn't. We didn't blow a fuse. Any voltage there? Read on low meter up. 1.6 volts. Okay, no voltage there. But since we have 1.6 volts, we don't have a short either, I don't think. No, there's no short across that main B plus. So nothing should go boom when I plug it in. Let's move some stuff around. Get that out of the way. All right. So this is plugged in. Let me show you what this is my supply. This is going to be a shaky cam video here, but I'm plugging into this variable AC supply here. Got an on-off switch on it, and I can vary the voltage up and down. So if I want to bring a power supply up slowly, I can start down here and just kind of bring it up. Usually somewhere around 60, 70 volts AC, they'll try to start. So anyway, but it makes it real handy to let me turn it on and off, so I'm not just plugging it in, with my bare hands, and less risk of getting shocked. So let's put you back in the tripod. I apologize for the shaky cam, but it is what it is. Let's see. So I'm going to plug this in. It's turned off right now. We'll put this back on voltage DC. And move some metal objects out of the way. Flip it on. So, do we have 5 volts standby? This is ground. We do not have 5. No, well, no, I saw 05. No. And let me check that right quick. I'm going to put my probes on those points. Turn it off. Wait a few seconds. I want to see if it's coming up and shutting down or not. Or if it's just never there. Gives you clues about things. Turning it on. No, it never tried. It never tried. Oh, wait a minute. Now it's suddenly there. Okay. That's weird. Was I not making a good connection earlier? It's there. Turn it off. Let it bleed off. Which is taking a long time. Because there's no load on it. AC power is off. Okay, now she's starting to bleed off. I'm going to let it bleed off, and we'll turn it on again. Very strange. That was not there earlier. Do we have an intermittent? But obviously there's nothing shorted in the 5 volt standby circuit. All right, I'm going to turn it back on. We're down to less than half a volt. All right, that's odd. It did not start up immediately. It didn't start up at all yet. So we are intermittently starting up. Nope, then she took off. That took a long time to start. I've never seen one do that before. All right, I've been doing some checking here, and I'm suspecting this DAP41. And let me show you why, if I could. This meter up here is looking at the output 5-volt standby. And this one I'm going to use to probe the supply pin of that DAP41, which is pin 6, right here. And I want to show you, it's got 1.1 volts on it right now. Let me show you what happens when I turn it on. Okay, we slowly start coming up, very slowly. This thing should turn on about 12 volts, and it's taking it a long time to get there. All right, she took off then, and she's putting out 4.8. That should not take that long. And the way this DAP41 works is it gets rectified line voltage on a high voltage pin, on pin 8 over here. And that's what it uses to start up. And for some reason, that is taking a long time to charge up the supply voltage in here. It does go through 2 resistors over here, two 2.7k ohm resistors, which seem fine. So I'm suspecting that something has taken a hit in here, because this thing is very close to the AC input. There's not much, between, if it was lightning, it may have damaged this thing. It didn't kill it totally, but it's acting very strange startup. So I think I'm going to swap that out and see if that changes our symptoms. Alright, well, that DAP041 has been changed out, and we need to see if we've had any effect, done any good with that. I'm still hooked up as I was, although my ground has come loose right there for my 5 volts. So this should be our 4.8 standby when it comes up, and this is I'm going to put on pin 6 of the DAP41. That's the supply voltage. I want to see, when it comes on and at what point it actually starts running and producing voltage. So let's see. Let me get ready. AC power. Now this is still. Am I not measuring my 5 volts? So do I not have 5 volts at all now? Thought maybe I had a loose connection over here, but I don't know that I do. Supply voltage is running about 11 volts. That looks normal. Although, I'm not sure if it should be varying around that much. So what's going on here? We're still not starting up. All right, a little time has passed. I think I finally found something. So let me figure out the best way to show this to you. But we're going to be looking in this little area right in here. Yeah. So let me switch to the microscope view. and show you what I'm talking about. I was just looking around the board, I noticed this resistor looked a little bit off. And if you zoom into it, let me just see. Oh, it's just got a hole in it. So, well, that's interesting. And sure enough, it is wide open. But what does it do? Does it matter for what we're trying to fix? Because I'm trying to get the 5-volt standby working right now. And this looks like, if you follow it down, it goes to the around there, around here. It goes to pin 3 of this IC. Let me get it in the shot. Pin 3 of and this is the power factor corrector IC. And this thing really doesn't have a lot to do with, with standby supply. This is normally just sitting there idle. This gets turned on as soon as you hit the enable. The enable goes high on the supply, and the 12 volts is called to run. Then this thing will turn on. There's not even any supply voltage to this IC in standby mode. So I'm thinking, okay, that's probably going to be a problem with the plus 12. I'll have to deal with that once I get the standby going. But I got to digging a little deeper and looking at where this is connected. And this is, by the way, is called, I'll show you in a minute on the data sheet. This is the current sense into this IC. Remember that, the current sense. So it goes to this resistor here, which is open, which looks to be a 221 ohm resistor. Kind of an odd value, but whatever. What's that connected to? If we follow it back, right here, and then there's a jumper from here to down here, a wire jumper, and that looks to be the negative side, if I can get it in the shot. This is the negative terminal of the bridge rectifier, the main bridge rectifier. So what they're doing, you see this point here, there's a resistor right here to right here. And that resistor is connected to, this is the negative terminal of the main filter capacitor. And let me try to show that to you on the data sheet, if I could. Let's see if it's going, how well this is going to show up. Focus. Okay. You see what they have here? This is the data sheet for that power factor corrector. And I did not know they did this, but here's the resistor, the comparable resistor. This is just an application note. This is not the exact diagram, but it's the same type thing. This is the common ground, and you'll have a filter capacitor out here. So this is giving them a sample point for all the current through the supply. Not just the 12 volt, the power for the 12 volt system, but all the current. And so that's in line with that negative terminal of that capacitor of your main bridge rectifier. And here you see they have an R2. This is would be like that 221 ohm resistor. Comes down here, goes to the current sense. So, and like I said, this is open, and this is open. I don't know the value of this resistor. I'm guessing it's a somewhat low resistance, low value resistance, since I'm going to be like a good bit of current go through. And they're just trying to sample that current and figure out what kind of draw the supply is having. So I'll have to get that one out and see if I can. I can't see it from the top side. But yeah, so my point is this resistor would affect both supplies, not just the 12 volt one, but the 5 volt standby. It would affect everything. And I'm not sure how this thing is even trying to run with that resistor open, but it's trying, and it will eventually take off and go. Probably wouldn't provide any real current, but it tries to run. So I need to replace definitely that, and that if we ever want the 12 volt system to work, for the power factor corrector to work. But yeah, so that does kind of make some sense. Let me see if I can figure out what this resistor is and if I have anything to replace it with, and see what I've got to replace this one with. All right, I've got this resistor out. Let's take a look at it. See what it is here. 0. Well, let me get it in the shot. Here we are. 0.1 ohms with a hole blown in the side of it. I think I do have these. 2-watt resistor. I think I have them. I think this will solve a lot of our problems. Alright, we're about ready to test. I replaced both resistors that I found open. The 220 ohms is the closest thing I had. I also did replace the power factor corrector IC, the 2PCS02 I think it is. Because, I mean, if the resistor going into it burned open, most than likely that chip had to have died, I would think. So, we are at the point of doing some checking. Alright. This meter is hooked to the 5-volt standby out, so we should get 4.8 there, and hopefully we'll get it immediately as soon as we turn it on. And then I've also got the little DC load set up if we get as far as getting 12 volts working. Let's see what happens with the 5 volts first. Immediate 4.8. Yes, that's a win. All right. Now, do we have 12 volts? Is that asking too much? Okay, this meter's not doing anything at the moment, so you can watch back here for the 11.8 volts or so to come up, if it will, maybe. If I can get on the right pins. There we go, look at 11.65 with a 6 amp current draw. The voltage reads low because of the loss across the wires. I'm pulling 6 amps, and these wires aren't quite big enough to... They'll handle the current, but you're going to have some voltage drop across them. So that looks good. Our 5 volt standby is working, and our 12 volts is working. I think this supply is fixed. Okay, we've dealt with that. We haven't even gotten to the HDMI encoder IC. But that looks encouraging. Moving on. HDMI encoder IC has been changed. I just want to do some quick checks before you stick it in the chassis, just to see if everything looks somewhat normal. Here I'll go to diode mode, red probe on ground. I've got my breakout board in here. Well, this was all shorted before. That looks good. 0.544. 2 is grounded. 3 should be similar. 543. 4 should be a similar reading. 5 should be grounded. 6, that looks good. 543. 7, 543. 8's grounded. 9, that looks good. 10, 560. 11's grounded. 12, 560. Then 13, we should have some kind of a diode type reading there. 14 is open. 15, well, 15 is shorted to ground. That's not good. 16 is shorted to ground. 17 is shorted to ground. So, do we have some bad diodes there, I wonder? And 19 should have a diode reading. That's open. 18 looks normal. 19 does not look normal. So let's go back. 15 shorted to ground. 16, 17, 18 is good. So 15, 16, 17, and 19 I need to look at. I wonder if this was a lightning strike, those Zehners that are on those lines probably are dead. So let me take a look at that. Alright, I think I figured out what's wrong with some of our shorts on this HDMI port. Yeah, like 15 is shorted, you know, like starting over here, this is 19, 18, 17, 16, 15. So 15 shorted Zener, and 16 right beside it here, you can see there's pin 16, shorted Zener. And of course 17 is supposed to be ground, so that's not a problem. That is ground. 18 is good. This Zener here still seems to be good, not shorted. 19 should have a diode reading on it though, and I don't have one. And I can show you why that is. Give me a second to flip this board over and get everything back in focus. Alright, pin 19 lands right here on this resistor. Like I've got my breakout board still plugged in, so I got one probe on 19. It lands right here. And I think this diode here is still good. It is. Let me make sure it's not open though. No, it seems to be good. So the diode is good, but you don't see it on, you know, measuring pin 19 because this resistor is open. This is a 22 ohm resistor. And I don't think I've ever seen one open, but it is open right now. It reads 200 and something mega ohms on my meter. So that's why, so 2 shorted Zehners on the other side for 15 and 16, and an open resistor on this one is why 19 is not reading properly. Let me get those swapped out, and I think we're going to be good then. Well, we are back out in the garage where it all began, and we are ready to find out if this PS4 is ready to turn on and give us some video. I don't have a hard drive. It did not come with a hard drive. I'll chase one of those down if this is working. But our repaired power supply is back in it. Not really screwed down, just sitting in there. And the Blu-ray is in there. I've cleaned that up. We're ready to see. I'm excited to see if we have any video. So let's see what happens. Alright, power supply came up. Looks good. Flashing blue light. The monitor locked. A PlayStation logo. Alright. I think we're going to be good. It's going to complain about not being able to find the storage, which is to be expected. But that is exciting to see. This thing was definitely lightning struck, I believe. All those shorted Zener diodes and the damage in the power supply and the HDMI encoder IC. So yeah, that's kind of a different one. I was hoping it might be interesting for some of you out there. So if it was, please give me a thumbs up, and I will see you in the next repair. So bye-bye for now.